Okay, I can see people flooding in now, so let's begin. So, hello, I hope everyone is well, and thank you very much for joining us today. This is the second part of a four-part webinar series where we are diving into each of the four domains of the AWS Certified Solutions Architect Associate certification. And the aim of this series is to give you an understanding and insight as to the sort of topics and areas that you should be familiar with when studying for the exam. If you have any questions as we go through the webinar, then please use the chat window to submit them, and we'll get to as many as we can as we go through our Q&A session towards the end. Now, before we begin, I'd just like to introduce ourselves and the panel today. So with me here, I have Stephen Cole, who is our AWS Certification Specialist and seasoned webinar presenter. So hi, Stephen. Thank you for joining me today.
Good morning. It's good to be here.
And of course, myself, I am Stuart Scott. I'm the AWS Content and Security Lead here at Cloud Academy. So let's move on to the agenda for today. Now, we have four subdomains from Domain 2 to discuss. And as we go through each of these subdomains, we will highlight some of the topics and services that you should be aware of to help you answer any questions that could potentially relate to the certification. Now, we've got quite a lot of content to get through within an hour, leaving some time for questions at the end. So let's get straight into it, starting with 2.1, identifying elastic and scalable compute solutions for a workload. Now, for me, the first thing that comes to mind when hearing elastic and scalable compute, I instantly think of EC2 auto scaling. Now, we did touch on this a bit in the previous webinar, but we looked at it from a multi-tier architecture perspective. So auto scaling does cover multiple domains within the certification, and so there should be some amount of effort into understanding what it is and how to use the service. You should really focus on when to use auto scaling, how it benefits your infrastructure, allowing it to both grow and shrink elastically, and the benefits that this provides. Another key element of understanding is the difference between both scaling up and down and in and out. Now, scaling up is when you increase the power of the instance. So, for example, going from a large to an extra large or two extra large. And scaling out adds additional instances to your EC2 fleet. So you might have two M4 larges and you'll scale out to 3 or 4 or 5. So just be sure that you understand the difference between those. And now, the best way to understand how this service is put together is to simply go ahead and use it. If you have an AWS account, play with auto scaling, get to learn the different configurations, learn about launch templates, understand what a launch template is, the contents, and the different configurable elements of it. In addition to auto scaling groups as well, where you can configure things like health checks and define your different instance purchase options. Do you have anything to add on auto scaling, Stephen?
Not, excuse me, not by itself. I think real quick that understanding the workload, certain types of workloads can only scale up. You can only make the instance bigger. Maybe for whatever reason it's not distributed in any way. So you need to recognize whether or not the workload behind the scenes is one that's distributed that you can add more instances, or maybe I can get a few low cost instances and add more compute power that way. And it's really recognizing the kind of workload that you need to manage to make it highly performant.
Yeah, definitely good point. Okay, so moving on to 2.2, looking at high performing and scalable storage solutions, of which there are a number of in AWS. So in this webinar, we're just going to focus on some of the core services, and we're going to start with EBS. Now, EBS provides persistent block level storage, as you may know. They can be attached to your EC2 instances. And it comes in the forms of volumes, so EBS volumes, and these are then associated with your instances. But if you terminate your instance, then you can keep your data on your EBS volumes. Like I said, they're persistent, and simply reattach it to another instance. But from a performance perspective, it offers two different storage types. So you have SSD backed and HDD backed. And as you can see on the table on the screen, now each of these storage types offers two different volume types. So be sure to look at the differences between them to get a better understanding of when you would use one storage type or volume type over another. It really does depend on your use case, which you select. So having an insight into the differences could help you answer any questions that might arise around EBS, because you're going to get questions, aren't you, Stephen, that are going to be guided in a very specific way in a specific use case that are looking for a certain volume type.
Exactly.
I've seen scenarios like that for sure.
Yeah, the thing that you're going to be really aware of is when do you really need something that requires provisioned IOPS? And if you don't know what that means, then you need to go study it. But the idea is that you need to understand like when I need solid throughput that's measurable, and then how to increase it or decrease it, and what burstable types are out there. Because some things work a little differently, and they have some scenarios that can kind of trip you up or trick you a little bit. But provisioned IOPS really, I mean, if I want high performance, like mission critical, low latency things, versus, well, every now and then I have a burstable workload. So you really need to know the difference between those two.
And it comes down to that. Usually that last sentence in the question is what they're really asking. And I know you've covered this many times before, Stephen. It's just really looking at the question to see exactly what they're after, because there could be two or three answers that would work for the solution, but it's picking the one that's most accurate for that question. So yeah, understanding those differences is quite key. Okay, moving on to Amazon S3, which looks after object storage. Now, as we know, this is a very widely used service, and it is covered in many of the AWS exams, and the Solutions Architect is no different for sure. It has a ton of use cases, and it's integrated with lots of other AWS services. From a scalable viewpoint, it's highly scalable. It's in fact promoted as having unlimited storage capacity, but you should bear in mind there are some limitations on the file size. The smallest file size supported is 0 bytes, and the largest being 5 terabytes. But if you have any objects that are larger than 100 megabytes, then you should use multi-part upload for S3. And what this would do, S3 will break that large object up into multiple parts of the object and upload them in parallel. And because of this parallel uploading of the parts, you get improved throughput. And then S3 will simply reassemble the object into a single object when it's back in S3. So if you're not familiar with multi-part, just take a look at it, understand what it does and how it can improve the throughput on larger objects. As you probably know, Amazon S3 has a range of different storage classes as well, each offering different performance and availability. The key ones to look out for are S3 Standard, S3 Intelligent Tiering, S3 Standard Infrequent Access, S3 One Zone Infrequent Access. So be aware again of when you should use each of these storage classes depending on your scenario. The final point on S3 that I want to mention is to do with S3 transfer acceleration. Again, you should definitely take a look at this if you're not familiar. What it generally allows you to do is dramatically speed up the transfer of data both into and out of Amazon S3 from and to your remote clients or another AWS region, for example. And it does this by utilizing the CloudFront edge locations to route requests through a high-speed and optimized AWS network path. So that's probably key points I would say from S3 from high performance. Do you have anything to add, Stephen?
No, I mean, I can't understate the importance of transfer acceleration when it comes to high performant workloads. It is something that shows up as a way to get your data in fast. I mean, CloudFront is important too, but if we're talking just native S3, really understanding how transfer acceleration works will go a long way to help you pass the exam.
Yeah, and I don't think this was covered in the old version of the Solutions Architect. I know it's is present in the new one, but I don't remember in the old one.
No, it
So
wasn't in the old one. It's definitely the new one. I had two questions when I took it about two or 3 weeks back.
well, there you go. Definitely worth taking a look at that one for sure. So the next storage service is EFS, so the Elastic File System. So we've looked at block storage with EBS, we've just looked at object storage with S3, and now we have file storage with EFS. Now, EFS is optimized for low latency access that can connect to literally thousands of concurrent EC2 instances. And it appears to the end users like a file manager interface, and it uses standard file system semantics such as locking files, renaming files, etc. So this type of storage allows you to store files that are accessible to network resources effectively. Now, looking at the performance of EFS, there are two different storage classes, these being standard and infrequent access. The standard storage class is the default storage used when using EFS, and you may have seen that if you've used it before. And infrequent access is generally used if you're storing data on EFS that is rarely accessed. It's much like the storage classes on S3. But the infrequent access offers a cost reduction on your storage. As a byproduct of the cheaper storage, it means that there is an increased first byte latency impact when both reading and writing data using the infrequency access class when compared to standard. So just bear that in mind if anything comes up regarding that. EFS also offers two different performance modes as well. General purpose, which is the default, and max IO. So ensure you understand the differences between these two modes to ensure you understand how performance and latency is affected between those two. And to make things even more confusing with EFS and performance, there's also two throughput modes as well. Firstly, bursting throughput, again, which is the default, and this scales as your EFS system grows. And it does this automatically, giving you more and more throughput as it scales, basically. Whereas provision throughput allows you to provision throughput of EFS regardless of the amount of data that you have stored within your EFS system. I think that covers the main performance aspects of EFS. Have I missed anything, Stephen?
No, you've covered all the bases are there. I mean, there's not a ton of specific questions on the exam regarding this, but you need to know when to use it and what might be a blocker if you're having some troubles, maybe what you should look at. But yeah,
it doesn't go into really great configurational detail, but just having an understanding of some of the different options available will certainly help. Okay, storage gateway. This is the final kind of storage service I want to discuss today. And for those that aren't aware of storage gateway, it's effectively a software appliance that's installed on premises, perhaps in your data center, and this allows integration between your own on-premise location, your own on-premise storage, and storage with that of AWS. So this helps you to scale your storage requirements both securely and also cost efficiently as well. Now, you have three different options when deploying storage gateway. You have your file, volume, and tape. Now, for the volume option, there's two different configurations, stored volumes and cache volumes. Now, I'm not going to go through and read all the different points on the screen. You can take a look back on this, but it gives you a good kind of overview of the differences between them. They do offer different levels of performance and capabilities, and again, it depends on the scenario or use case. So just be careful to look at the question to understand exactly what they're asking if you get any questions on storage gateway, whether you'll need to use file, a stored or tape gateway.
You know, I think, Stu, that for the exam, I mean, you really need to know what these three things do. And sometimes high performant means less about the ability to run it fast and making sure that it works consistently. So if you need to move data from one place to another, you're on premises and you need to get it into the cloud fast, this is one of those tools that can help you make that happen. And you really need to understand how the different gateways work and how the tape gateway works, and that it and how the cached volume gateways work. If you just try to guess, you're gonna be wrong. So you really need to know how to configure, how to build your on-premises hybrid AWS kind of configuration so that you can use these things effectively and efficiently.
Yeah, definitely, because there's some big differences between them. Some of them store the primary data set on premise, some of them store it in AWS. So there are some big differences between them. So yeah, you're absolutely right there, Stephen. Now, something else that we just thought of actually is AWS, is it FSx Luster? Is that right,
Yes.
Stephen? It is, isn't it? Yeah. Should have put a little bit something in about that. Definitely take a look at that service, that storage service. Just have an overview of what it is, when it's used, and the kind of service it provides as well. I could have listed lots of other storage services that could potentially come up in the Solutions Architect Associate, but I just wanted to bring that to attention as well. Do you have any other points to say about that service, Stephen?
Luster is kind of was a Windows centric way of doing EFS, or like kind of an NFS implementation. So being aware of when you want to have a high performant disk system that you can share amongst multiple clients, and just kind of understand what the benefits are. It's usually more of an architecting for resilience, or architecting for high availability, less about performance. But every now and then, you can mount a drive and copy data easily. So those kinds of scenarios might show up.
Awesome, thank you. Okay, so we're now moving on to 2.3, where we're looking at features and services that cover high-performing network solutions, starting with the Elastic Network Adapter. Now, the ENA is a custom interface, which is used to optimize network performance, and this allows you to reach much greater speeds, up to 100 gigabits per second for your Linux compute instances. But do be aware though that this is only supported on a limited number of instances at the moment, and I've just added those at the bottom of the screen there. This is probably going to change over time, as all things do with AWS, as new instances are supported, etc. But don't worry about that too much, because you're not going to get tested on which instances are supported by ENA, so don't worry about memorizing those at all. I just wanted to highlight that it's not applicable to all instance types. It also offers higher bandwidth with increased packet per second performance. And if you launch an Amazon Linux 2 AMI today, then by default it will have enhanced networking enabled, obviously as long as it's launched on one of those supported instance types. So basically, if you need enhanced networking performance in your environment on your Linux EC2 instances, then you should use the Elastic Network Adapter and just enable it on a supported instance type. And this can be, you can check to see if it's running using the AWS CLI, and if it's not, you can quickly and easily enable it as well using the CLI command. Anything else, Stephen, from
No, I mean, I mean, I think that this stuff is, I mean, this material covers all of it. It's really kind of, you might be asked to be aware of X, Y, and Z, and maybe X is, hey, I've got a slower machine with a newer machine, and I can't figure out why it's not going fast. And it's, oh, we probably have the wrong instance types, and they're not talking in the same fabric. So
And again, it's one of those things where you're not going to be asked real detailed configurational questions on this. It's more of an awareness that it exists and what it does and what it can do. I would say for the associate level. Would you agree?
I totally would agree.
Yeah. I mean, this might come up a lot more detailed in the networking specialty certification or the professional level, but for the solutions architect associate, it's more of a high level understanding that this feature exists and what it does. Okay, moving on to the next point, VPC endpoints. For those unfamiliar with VPC endpoints, they allow you to privately access AWS services using the internal high-speed AWS network instead of connecting to them via the internet using typical public DNS endpoints. And so this helps to really increase the network performance and security of those connections. And also that means you can connect to the services without configuring an internet gateway or a NAT gateway that you might need otherwise. There are two types that you should be familiar with. These are interface endpoints and gateway endpoints. Now, the interface endpoints are essentially ENIs, elastic network interfaces, within a subnet that act as a target for traffic being sent to one of the supported services. And this operates via private link. Now, private link simply allows a private and secure connection between VPCs, AWS services, and on-premise applications via the AWS internal network. Whereas gateway endpoints, they act as a target used within your route tables to allow you to reach supported services, which are currently only S3 and DynamoDB. But again, that may change over time, but they're the options for your gateway endpoints at this stage. Anything to add, Stephen?
No, but other than the fact that this is something you really need to know about for not just this domain, this is a thing that comes up, especially for security. But the idea that you can create these pathways, excuse me, from one place to another inside AWS, critically important for high performant workloads. Making sure that you don't have to rely on sending things through the internet gateway to get from one place to the other. Also make sure that those high performant computing workloads stay up, because you can keep them. They're yours. They're your pathways that you build, as opposed to, oh, send it up to the internet gateway and pray.
That's right. And generally, as a general rule, if there's a question asking about better performance and bandwidth and security, and there's an option to use the internal AWS network, that's probably going to be the correct answer. As a general rule, I mean, I don't want to say for everything,
Exactly.
but if there's a question asking around those kind of elements, should you go out to the internet or internal AWS network, especially from a performance standpoint, it's usually going to be the internal AWS network. And like you say, this methodology kind of goes through the other AWS certs as well, doesn't it?
Yes, it does.
Okay. Next up, we have the AWS Global Accelerator. Again, it's another performance enhancing network component, and it's a global service as well, so it's not tied to any specific region. And the main aim of it is to get both UDP and TCP traffic from your end user clients to your applications faster, quicker, and more reliably. Again, through the use of the AWS global infrastructure and specified endpoints. If you've not used it before, it uses two static IP addresses which are associated with a DNS name, and this is used as a fixed source to gain access to your application in your environment. And this could be sitting behind a load balancer, or it could be directly connected to an EC2 instance or an elastic IP address. Now these IP addresses can also be mapped to multiple different endpoints as well, which could each be in a different region and this helps to enhance performance of routing choices as well. Now, because the routing of your request is based across the AWS global infrastructure, the Global Accelerator intelligently routes customers' requests across the most optimized path using the global reach of edge locations. So again, it goes back to that own AWS network being the most optimized route. You shouldn't see any deep questions on the configuration of the Global Accelerator, but you should certainly be aware of what it is, when it's used, and the benefits that it provides. So it's very much like the ENA we spoke about earlier. You don't need to know the deep ins and outs of the Global Accelerator, but you certainly need to be aware of the kind of performance it can help with from a network perspective and what it does.
Exactly. Sometimes it'll be show up as a distractor. So you have the main question, and then a bunch of which is the item itself, and then the possible answers. And Global Accelerator could be in there, and you need to understand. Oh, I have this global network, and I have this globally available application, and I need to move data from one region to another, and I need to do X, Y, and Z. How can I make this thing be highly performant and scale and move data around? And sometimes the answer is the Global Accelerator. Sometimes it's going to be something related to CloudFront. Sometimes it's going to be related to a direct connect or the direct connect gateway. So you need to really understand how these things kind of relate to each other and the type of workload that you're running, that you need to move data from one place, one region to another.
All good points. Definitely. Totally agree with that. Okay. Amazon Route 53. When it comes to this service, there's definitely a number of elements that you should understand and know how to implement. First and foremost, understand the core components of the service and how it operates. Know the differences between public and private hosted zones and when you use each one. Also, some of the different domain types, such as top-level domains and geographic domains. I'll tell you one of the most important factors of Route 53 from a certification standpoint, and I don't know if you'd agree, Stephen, is I always say is the routing policies.
Absolutely.
Yeah. As you can see, I've got them on the right-hand side there. They each offer different routing factors based on different circumstances, and selecting the right routing policy will definitely enable you to implement a high-performing DNS system for your solutions. So certainly read over those different routing policies. I could almost guarantee that something would come up relating to Route 53 and routing options. So you definitely need to have a good grasp of understanding those.
I think too that I mean when you look at the policies to route data from one place to another, sometimes you'll see questions about failover and how do I stay up and highly available. But highly performant means that I really want my end users to have a highly responsive application and a highly responsive experience. And so those kinds of routing policies are going to be around latency and geolocation and geoproximity. And there's a little difference between geolocation and geoproximity. You need to understand what they are and not necessarily how to build them. Like it's not going to say, okay, what is the command line option to turn this thing on? Because that would drive me insane. And that's not there. It's really understanding which way would I look at this problem to make it work for me. And it's not going to be, so it's going to be very much like, oh, I need to set up a Route 53 and we need to do this kind of thing, and I have to know where my users are, and so I want to make sure that they point at the right thing. And once you've got that figured out, then you'll know the answer.
Agree. I agree. There's a lot to Route 53. There's a lot of different elements. So just make sure you have a good understanding, and again, just read over those routing policies. The last service I want to mention under this subdomain is CloudFront. You've probably all heard of CloudFront when we've mentioned it a few times already. It speeds up the distribution of both static and dynamic content by storing cache data through its, again, worldwide network of edge locations. Now, it feels like I've mentioned the edge locations and global network a few times today, and that's why I highlighted it in the very first of these series of these webinars as something to really get a hold of and get a grasp of. You really need to understand the AWS global infrastructure because it really helps you on so many different questions and services. But anyway, normally when a user requests content that you're hosting without a content delivery network, a CDN, the request is routed back to the source web server, which could reside in a different country or continent to the user that's initiating the request. However, if you're using CloudFront, the request is routed to the closest edge location to the user's location, which will likely provide the lowest latency and therefore deliver the best performance through its cache data. Much like Route 53, understanding CloudFront comes down to understanding its components. And one of the main components of CloudFront is the distributions. So look into what they are, understand them, how they're used, and be aware of the different types of distributions as well. I mean, there's currently two types, web and RTMP, but I realized that the support for RTMP is actually being discontinued at the end of this year. And I looked into this, and this is largely down to the fact that Adobe has announced the end of life for Flash on the 31st of December 2020, which is largely what RTMP was mainly used for. One of the points to look into are the caching behavior options for CloudFront as well. Look at the different options here, how they're configured. You don't need deep knowledge, but an awareness of these caching behaviors could help you, could be beneficial.
Absolutely. Caching makes data throughput faster, right? That's going to make it highly performant. But cache data is also stale data. So you have to understand that when you put static assets, if you know if it's static, then hey, putting it in a CloudFront edge location, that's going to be probably a good thing. But if it's dynamic content, knowing how you're going to refresh data and how you're going to maybe use it or not use it with CloudFront, those are the things that really start to show up in the exam. So being aware of how do I manage data that could be stale. If it's a once a month report, hey, not a problem. That's an easy peasy thing. But if it's a stock report or a cost measurement thing, maybe a 5-minute delay is going to be a problem or something like that, then you need to understand where data should be coming from and what that origin is. And it's just really, again, not how do you build it, but what is its impact in my workload?
Yeah. Nice, thank you, Stephen. I think that's the last of 2.3. So now moving on to 2.4, which is the final subdomain for domain 2. And this looks at high-performing database solutions for workload. I know you've been working on a lot of database content recently, Stephen, so a lot of this should be fairly fresh in your head. We'll start with RDS. Now, RDS allows you to use multiple different database engines across numerous different instance types, each offering their own levels of performance. And again, this depends on your use case. Now, you can see on the screen here, we have compute optimized, memory optimized, storage optimized, and also accelerated computing. Now, each of these categories have instances that excel in each of these areas. So again, it's based upon your use case or scenario. So depending on the question, you have the flexibility within RDS of provisioning the right performance enhanced instance. In addition to the different instance types that are available, RDS also has multiple storage options, again, each offering different levels of performance. Generally, you'd select between general purpose SSD and provisioned IOPS. If your workload has a requirement for very high IO, then you'd be best to select provisioned IOPS 2, reduce latency, and increase throughput. Magnetic storage is only there for backwards compatibility now, really. Do you have anything else to add on performance on RDS from this standpoint, Stephen?
No, I mean, it's funny because I rarely use the word high performant and database in the same sentence if I can avoid it. But so part of it is really an architecting thing. How do I minimize the impact of my various types of reporting and workloads? But you really need to understand, oh, is this particular workload something that really runs well in RAM? Is this something, so I need a high memory optimization kind of thing, a database available to me? Is this something that's, I'm going to do a lot of stored procedures and calculations? Then at that point, then I need to know that. It's much more really recognizing the workload that you have.
Excellent, thank you. Okay, RDS Insights. I know you've just recently created a course on this, Stephen. So do you want to give us an overview of this?
Certainly. So RDS Insights is a way to look at the load that your SQL statements, your relational database has on it in terms of the queries. So you can do metric evaluation and monitoring of your RDS instance, and you can see how much network it's using and how much disk it's using, and you can see all of these things happening. But you have no way of seeing without kind of guessing and a little bit of magic, a little bit of dark magic to understand what's happening inside the database on its own. So AWS created something called RDS Insights, and they have this metric called average active sessions. And what they look at is every database has the ability to see the number of connections that are attached to it, like what's actually doing work, and they can take a look at that and take a snapshot of that workload in memory, look at what's happening, and they can report on it. So when you want to know if the problem is with your network or your problem is with your database, you can actually go into RDS Insights directly and say, well, it looks like this database is doing nothing, but it's going really slow. It's probably not the database itself. Or you can go in and you can look at RDS Insights on these relational database instances, and you can say, well, it looks like we are pegged on this one particular query. Somebody's running something that they don't know how SQL works, and it's causing everybody else to be delayed. So the workload backup, the problem that's causing all of the issues is on the database. So this gives you, as the name describes, it gives you some insight to how the SQL queries are performing. So this is a thing that when it shows up on the exam as a tool, like I see that this is happening, and I go in RDS Insights and I see that I've got that it's maxed out on my AAS, my average active sessions, at 100%. Well, then you know that that's the problem, as opposed to you see the opposite, where hey, I go into RDS Insights and it says that I've got 0 active sessions. Well, then the database is not the problem. So it just kind of helps you troubleshoot where the issue is when it comes to when it's not working as you expect.
So useful tool then for sure.
Absolutely.
Excellent, thanks for that, Stephen. So moving on to Amazon DynamoDB. This is designed for ultra high performance, which can be maintained at pretty much any scale with a single digit latency. And when it comes to performance features of DynamoDB, you can configure the throughput of your tables using defined capacity, and this is measured in capacity units, either RCU for read capacity units or WCU for write capacity units. And there's also 2 different modes, provisioned and on demand. Now, you generally use the provisioned option when you have a good understanding of the expected and forecasted workload that your database is going to get in production. But if you're unsure of the workload, then the better option of the 2 would be to use on demand, and your capacity units will scale as they need to. Of course, over time, you'd gain a better understanding of what the expected throughput is, and you can switch to provision deployment, which would also be more cost effective. Do you have anything on DynamoDB, Stephen?
I think that from this slide specifically, using provisioned allows you to give the bean counters, the people that pay the bills, the idea of, oh, I know what this cost is going to be. The problem is that if you have a high performant database or high performant workload and you exceed the provision capacity, you will be throttled. What will happen is you'll hit that top edge of your provision space, and your application will stop working the way you expect, and you're going to be like, what the heck just happened? Get the number of that truck, because something's not right. And so it's really a matter of re-architecting it to say, oh, maybe I need to have an auto scaling kind of on demand thing to manage, or system to pay, or to manage my DynamoDB workload until I can figure out what the actual workload is going to be. So, I mean, you might see something like, I have this highly performant system, it's working great, and it stops working. And one of the answers could be, oh, you provisioned your workloads, your read and write capacity units too low, and you're now being throttled because you exceeded what you've paid for.
Mm-hmm. Excellent. Thank you, Stephen. Now I think we have the final slide on 2.4 before we jump into our Q&A session. And this covers the DynamoDB accelerator known as DAX. Now, of course, and as the name suggests, this can be used in conjunction with DynamoDB to enhance and offer extreme performance. It's an in-memory cache, and this increases DynamoDB's performance tenfold compared to the default DynamoDB settings. And as a result, the response times go from milliseconds down to microseconds. And it's also massively scalable as well. It's capable of handling millions of requests per second. Now, for the certification, you don't need deep technical knowledge of DAX, but you should certainly be aware of what it offers DynamoDB, and when you might use it within the solution to enhance the performance, especially when it comes to read queries, etc. So that's pretty much it from myself. Before we move on to Q&A, do you have anything on DAX before we move on to Q&A, Stephen?
I don't think everything that you haven't said, but I have to say it's on the exam. You really need to understand that what it does, that it's an inline cache. You might not need. I'm in the process of ramping my developer associate exam or certification is about to expire, and so I'm looking at some of those tools. You might see it more there as far as a tool on what you're going to use it for. But from an architecting perspective, DAX is one of those ways to have a super high performant throughput into DynamoDB and back out again. And so you really need to know what it can do for you. Not necessarily how, but what it can do for you.
Yeah, definitely. Okay, so we've gone through a lot of the content, so we'll move on to some Q&A and take a look at some of the questions that have come in. Stephen, do you want to start off?
Yeah, so we have a couple questions from the audience. The first one was, does transfer acceleration, and I'm guessing this is for S3, transfer acceleration work for reads or only updating data? And my understanding of transfer acceleration is that it's basically a client server kind of thing, where you have the client loaded on your whatever workstation, either locally or in the cloud, and it basically increases the throughput to and from. Am I misremembering that?
No, I would agree. I mean, I'd say it's more for literally the transfer of the data between the two endpoints, that the speed is accelerated. So no, I think you're right.
Yeah. The second question is kind of funny because I remember when the feature was added and then kind of went away. The question was on RRS, the reduced redundancy storage versus S3 one zone IA. And so what happened with reduced redundancy storage RRS on S3 is that AWS had some customers that said, hey, we don't really need all of these copies of data. We don't really want to pay for all of these copies of data for this redundancy. We just need some temporary storage. We think you could save us some money if we didn't make lots of copies of it to make it redundant. So AWS created this new feature inside of S3 called RRS, reduced redundancy. So the theory was you would pay less for it. Well, what happened was that not a lot of people used it, and then people were using S3 general, the general whatever it's called, general access, general provisioning. It's too early for me.
Standard.
Standard, there it is. Standard access, and yeah, because G generally that's EBS. So more people used it, and it brought the cost down for S3 in general, and so RRS was actually more expensive than it was for to do the S3 standard access. So it was like, don't use it. It's more expensive. It's not a good idea. So because of that, it's still there. If you look for it, you can still find it. Don't, because it's expensive. Um, the
Yeah, AWS doesn't actually recommend using it anymore, do they?
No,
Uh,
they say don't, because it literally is more expensive than any of the other options now. But because the APIs are contracted, these are all contracts that AWS has with its customers. They don't go away. Eventually, they'll be deprecated, but as long as one customer uses it, it stays. So why would you use the different storage classes? Well, it's all about cost, but you would not use RRS, not on a
no,
bet.
I mean, so the S3 one zone IA is cheaper and better, offers more than RRS. So
Correct.
it's that's kind of largely why AWS say don't use this, even though it's still here.
And then there were two questions about the differences between ENA and EFA, so the Elastic Network Adapter and the Elastic Fabric Adapter. And what I know about the Elastic Fabric Adapter is that I know enough to not use it because I don't have a workload that needs it. It's really designed. It's kind of
I think
like
it's better
having,
for high performance computing and kind of ML workloads, when you've kind of got inter-node connectivity
yeah.
between those environments. I think that's when you'd use the Elastic Fabric Adapter.
Yeah,
Whereas
so
the
like if you have a placement group and you've got everything like really close to each other, and you have another type of node that's maybe in the same VPC that you want to have a lot of the GPU calls thrown between the two of them, you're gonna put all of that same content on the same network fabric. It's gonna be isolated. It's gonna be for you. It will not show up on the S3 or the Solutions Architect Associate exam. You will not see it.
no,
Or if you
no.
do, send me a note so that I can eat my words. I'll print them out on the paper. But
If it is there, it's probably going to be a distractor rather than anything
correct
else.
is the answer. Elastic network adapters, really know what that is, what the concept is, versus an ENI, the Elastic Network Interface, because they do different things. Because then the next question down was, is ENA available across all regions? And I think so, but I don't know. I would have to look at the docs. I think
Yeah,
it's
I'd have
available in
have
all
to look at that.
commercial regions where those instances are available, but I don't know.
Yeah, I'm off the top of my head, I'm not sure if it's available
Yeah,
in all.
I mean, it's been available. I mean, it went into general release like in 2016 as far as a thing. So I'm pretty sure that it has moved its way to all the commercial regions. I tend not to look at the China region, and I tend not to look at the Gov Cloud because those are not places I do workloads anymore. Um, So that's not a thing that I'm worried about. Um, the next question down is Amazon CloudFront versus Amazon Global Accelerator, which to choose for performance. And I think I'll hand this one off to Stu. What do you think?
Yeah, well, CloudFront manages HTTP, whereas the Global Accelerator is more UDP and TCP. So they're kind of very different services managing different protocols. So it depends on what you're trying to distribute across your solution, really. If you're working with HTTP traffic, then the Amazon CloudFront is a great choice. You have your edge locations worldwide, great for caching data, whereas the Global Accelerator works with UDP and TCP connections, and there's not really any kind of caching involved.
Exactly. With the Global Accelerator, you're looking at a way to move all kinds of network traffic from region to region, availability zone to availability zone. Whereas with CloudFront, you're going to create a distribution, you're going to point a website at it, and you're going to download data, you're going to upload data to it. Then the last question that is on our list, and we are great on time today, is Elasticache versus DAX. Performance-wise, which one to use? And I have my opinions on this. What do you think, Stu?
Well, DAX is only available for DynamoDB. Elasticache, I think that uses Redis and Memcached. Is that correct?
Correct.
I haven't used Elasticache for quite some time. So feel free to step in and give me your opinions.
So DAX is basically API compatible with DynamoDB. You don't have to rewrite your application at all. You basically change the endpoint, you use the DAX endpoint, and it runs faster. And you don't have to re-architect or redesign. It's just a different endpoint through DynamoDB. Whereas Elasticache, you're going to build the cache, right? You need to know what your application is doing. Maybe you're going to build something for a relational database. You need to improve throughput on that, and you don't necessarily want to create a brand new database. So you can create either a smarter cache with Redis that's got the ability to survive reboots, and it's got some persistence. Can be. The database has some persistence. I can't even say the word persistent. Persistence. Holy cow, it's too early. Too early. I need more coffee. But you would have to decide, am I going to build a side cache? Am I going to build a cache that goes like a through cache? What is this going to be? What kind of thing do I have to do? A lot of times, you could build it in such a way that, hey, this sits in front of my database, and this is going to be like kind of the middle spot for it, and let it do all the work for me. It just really depends on your workload. But I can tell you for sure that if already using DynamoDB, the DAX is your cache. If you've got anything else, you could use DynamoDB as a cache in front of RDS, not a problem. You could you could create queues, and you could do some decoupling, and you could do all of this fancy schmancy stuff, but you're going to have to write some code, or you're going to have some way of getting the data out of DynamoDB into wherever it's going to go, whether it be, hey, I'm going to send it into a Kinesis Firehose or Kinesis Stream, or I'm going to send it to RDS, I'm going to send it to S3. I don't know where it's going to go, but I'm going to have some process for that. But if you're just storing data in DynamoDB, done. That's where it is, go. And I can use it's just got a different endpoint and with no code changes whatsoever.
Nice, excellent. Thank you,
Yeah,
Stephen.
Elasticache is fun and exciting if you like such things. To me, it gives me a headache after a while. That's me. But it's neat because like Memcached, I just need a fast cache that has no intelligence, right? It just basically is a cache. I put data in, I get data out. I have it talk to something else. It's an intermediate step. With Redis, it is a kitchen sink if I'm going to use that kind of generic English. I can have data have certain lifetime to live. I can say, oh, this data is going to expire after a while. I can set up persistence. If I lose the Elasticache instance, I can take a backup of it. I can restore it. It's all kinds of stuff to do, but it's really dependent on the workload itself.
Excellent, thank you for that. Just one other point I want to make on that previous question, when we was talking about CloudFront and Global Accelerator. One of the key differentiators as well with the Global Accelerator is it's the communication between your end client and your applications using intelligent routing across the global infrastructure. So that's very different from caching HTTP traffic using CloudFront. So yeah, I just wanted to add that part to that question earlier.
Very
okay,
cool. That's all the questions we had.
Yeah, that's all the questions. So I think we're kind of at the end now. So which is great. It's been a good session. Just want to quickly highlight that we have our learning path here at Cloud Academy covering the AWS Solutions Architect Associate. And this will help you prepare for the certification. It has a number of courses, hands-on labs, some challenge labs in there, a couple of webinars where we talk about different elements, and also a preparation exam as well. So if you haven't checked it out, then please do so. That brings us to the end. So again, thank you all for joining us today, and a special thanks to you, Stephen, for joining me to cover the topics across Domain 2. There was a lot to cover. I think we've done it just in time, and hopefully it's given you some insight into certain areas that you might want to explore in greater detail throughout your study. Now, part 3 in this series will be coming shortly, where we shall be discussing Domain 3, design secure applications and architectures. So that's it for me. Do you have any closing words, Stephen?
I think just want to say thanks everybody for being part of our session today, and looking forward to see you online. Feel free to connect. Both of us are available on LinkedIn as well as Twitter. I don't really do a ton of Twitter stuff, but I try to show up on LinkedIn as often as I can, answering questions and being part of the community.
Cheers. Thanks very much. Speak to you soon. Bye.
Bye.